Good morning. We're going to start Unit 1, Tools of Geometry. Today's objective is to be able to define geometric vocabulary and also to be able to name points, lines, and planes. So our first vocab term is point. And a point has no dimension. It is represented with a dot. So all points are represented with a dot. And then we are actually going to name points with a capital letter. So on that last bullet point, that's where we're going to write name with capital letter. So all points are always named with a capital letter. Our line actually extends in one dimension. So lines go on forever, and so they extend forever, and so that's why it's going to be represented with a straight line with two arrowheads, because it goes on forever. Now there might be multiple points on our line, so this could be A, B, C, and D, and the way we're going to name that is we're going to name with two of those points on the line. So I could choose any 2 points on that line, and to name it, if I wanted to name it with B and C, I would choose capital letter B, capital letter C, and then I'm going to put the little line symbol above those 2 letters I chose. So that's line BC. Sometimes you'll also see little script letters, and you can also name lines with a little script letter as well. So that's another way to name a line. A plane actually extends in 2 dimensions. So we're talking about like something that looks like a tablet or a wall, and it actually extends forever, and it is named with 3 capital letters. So you are always going to choose 3 letters, and those 3 letters have to come from the plane. They have to be inside or on the plane. So if we have point X, point Y, and point Z that are all in this plane, then we would name this plane, and we don't really have a symbol for plane, so we just say plane X, Y, Z. You cannot choose a point outside the plane. So if there was a point outside the plane, and let's say we had a line that went through the plane, you could not choose this point W because W is not on the plane. Also, sometimes we'll see that the plane is named with a capital script letter. So sometimes you might see a capital script letter, like maybe a uppercase script B. You can also name planes with a capital script letter. Okay, then we have collinear points. The term co just means that they are going to lie on the same line. So since it's co and we're talking about a line, that means they're points that lie on the same line. So any points that lie on the same line are called collinear points. So all of those are collinear because they lie on the same line. Points that lie on the same plane are called coplanar points. So those would be all points that lie on the same plane. They can be on the side, in it, as long as they all lie in the same plane. Those are called collinear. Then we have a line segment. A line segment is a part of a line, and it's the part of the line that consists of 2 points, which are called endpoints, because the segment does not go on forever. So we have 2 points called endpoints, and then all the points in between those. And so instead of it going on forever, a segment stops at those endpoints. So maybe we have X and Z, and there can be any point. I mean, all points are in between X and Z, but our endpoints are X and Z. And so the way we name a line segment is we do name it with the 2 letters of the endpoints. So this would be segment XY. And so you write down your X and your Y, they're capital letters, and you put a segment line on top of your XY. Then we have array. Array is the part of a line, so this is still part of a line, but it consists of a point called an initial point. And the reason it's called an initial point is because this is the point we're going to start with, and then we're going to take all the points that extend in one direction. So if we're on a line and I take a point off my line, so let's say X, and then I'm going to look at the line in one direction or the other. So maybe I go X, Y. So it extends in one direction. And so the way I name array is I'm going to name it with the endpoint. And one other point on the ray. So in this case, I would name this ray XY. And the way we name array is we actually put a ray symbol on top of those two letters, XY. Okay, then we have, whoops, sorry. Okay, so then we have opposite rays. Now, there is a little correction you need to make in your notes. So if we have C between A and B, so in other words, we have A and B somewhere on a line. Here's A, here's B. Somewhere in between A and B, there is C. Opposite rays would be ray CA and ray CB. They both share an endpoint. They both share the, or sorry, not endpoint, the initial point of C. And then one goes to the left and one goes to the right. So ray CA and CB are opposite rays because they share the initial point C, except one goes to the left and one goes in the opposite direction to the right. So the part of the notes you need to make your correction on are right here. Ray CB and CA are known as opposite rays. Intersect, the word intersect, that's when two or more geometric figures have one or more point in common. And an intersection is the set of points that a two geometric figure has in common. So we're going to look at a couple of postulates. And these are important ideas that we need to keep in mind as we're moving through our examples. As long as you have any 2 points, through any 2 points you may have, there is exactly one line. So it doesn't matter where your points are. Through any 2 points, there is exactly one line. So even if I put a point over here, I could make a line with these 2 points, or I could make a line with these 2 points. So through any 2 points, there is exactly one line. Postulate 1-2, if 2 distinct lines intersect, they intersect at only one point. So if we have line M, I'm going to name it with that lowercase script letter, and line N, they intersect at exactly one point. They don't intersect at multiple points. Postulate 1-3 says, though, that if 2 distinct planes intersect, they actually intersect at a line. So if I have plane, and we're going to name this plane R, a capital script letter R, and then I'm going to choose a different color here. We're going to use purple. And then I have plane, let's say S. This one's a little harder to show. Those 2 planes actually intersect at a line, and I will demonstrate this in class because this one's a little harder to visualize, but they actually intersect in a single line. So different from your lines intersecting, when your planes intersect, they actually have multiple points in common, and where those 2 planes meet, they intersect at a line. And then postulate 1-4. Through any three non-collinear points, there is exactly one plane. So remember, non-collinear means that the 3 points are not in the same line. So you can't draw 1, 2, 3. Those are collinear. So we're talking about non-collinear points. So through those 3, there is exactly one plane. So as long as you have 3 non-collinear points, there is always a plane that could exist between those 3 points. All right, so now for some examples. We're going to use the figure to answer the question. Name a line that contains point D. So we're going to find and locate point D, which is right here. So you actually have 2 ways to name that line. You can name that line CD. You could name it DC, doesn't matter the order of those letters. Or we can name it with that lowercase script letter line P. Name a point contained in line N. So we're going to locate line N, which is right here. They use that lowercase script letter. And so we're going to name one of those points. So you can either name point A or point B. Name the plane containing lines N and P. So the plane that contains both lines N and P would be this plane. So we have 2 ways to name a plane. We can always name it with the capital script letter that I see here in the corner. So I could name that with plane G. Or you have to choose 3 non-collinear points. So that would be C, A, and B. You could also choose D, A, and B. Any 3 that are not on the same line. I'm going to choose plane C, A, and B. Does line N intersect line P? Well, it doesn't appear that they do because it doesn't look like they intersect, but you have to remember that lines go on forever. So if I extend line P, it does intersect eventually with line N. So yes, they do end up intersecting because lines go on forever. Example 2. We're going to use the figure again to answer the questions. So name the points that determine plane R. So again, we either have to choose 3 non-collinear points. So I could choose X, Y, and Z. Or I could choose the capital script letter. And in this case, it is R. So I could use that capital script letter R. Name a point at which M intersects R. So I want to know where line M intersects plane R. So where does that line intersect with this plane? And notice that line goes through the plane, and where it actually goes through the plane is where it intersects right there, which would be point Z. So we're going to name Z our point. What is another name for line M? So that little script, lowercase script letter is line M. And so the only other way we know to name a line is through 2 points on that line. And so the only 2 points we see are Z and W. So remember we put the line with the 2 arrows above, and you can do those in any order, WZ or ZW. Name 2 lines in plane R that intersect with M. So what 2 lines intersect with line M? Well, this line right here intersects with line M, the yellow line. And so we're going to name that line XZ. You could also name it line ZX. And then our other line that intersects with that yellow line would be this one right here. And notice the only 2 letters on that line are Y and Z, so I only have one choice to name that. So I can either name it YZ or ZY. And then the last question is name a line in plane R that does not intersect M. So I want to know what line does not intersect that yellow line. And the only line that does not intersect that yellow line would be the line at the bottom, which is line XY, or you could also name it YX. And I need my arrows at the top to indicate that's a line and not a segment. Example 3. How many planes are shown in the figure? So how many planes do we have? Well, we have, remember, through any 3 points, there's a plane. So I have this plane up here, which is 1. I have the plane on the back of this figure, which would be 2. I have the plane to the right, which is 3. I have the plane to the left, which is 4. And this is where it gets a little confusing. You might think there's 2 more, 5 and 6. However, if you notice the bottom, this bottom piece is actually on this plane. So there are really only 5 planes here. So there are a total of 5 planes shown. How many of the planes contain points F and E? So how many contain F and E? So F and E is contained in this plane, the top plane, and they're both also contained in this plane. So they are only contained in 2 planes. Name 4 points that are coplanar. Coplanar means they lie in the same plane. So if I take this, for example, this plane right here, I have 4 points that lie in that plane. I have B, C, E, and D. Or I could also look over at the plane on the left, and I have 4 points on that one. F, E, A, B. I could also do it for the back plane as well. You just have to choose one set of those. So the back plane would be F, D, C, and A. So I'm just going to write down F, C, D, and A for my 4 points. They all lie in one plane. Are points A, B, and C coplanar? Yes, A, B, and C lie in the same plane, so they are called coplanar. They all lie on plane W, so they are all in the same plane, A, B, and C. And what is the intersection of plane FEB? So I want to know, where does plane FEB, so I only have to name it with 3 points, so we're talking about this plane right here. Where does plane FEB intersect with plane DEC? So DEC would be this plane to the right. Now, if we remember back to those postulates, any 2 planes intersect in a line. And so if I look at this, those 2 planes intersect at this line right here, which would be, I believe that is point E that I have now covered, and B. So they actually intersect in a line, and that is line EB. So 2 planes always intersect to form a line. And last but not least, we do have example 4. Draw the following. Line Q and line S intersect at point T. So let's start there. We have line Q. We have line S. They intersect, so where they intersect at point T, and then they all lie in plane A. So that would be your quick little sketch of what that would look like. It doesn't have to be beautiful. Notice mine's not beautiful. I'm drawing on the iPad. So line M and point T. So I have a line M and point T are contained in plane D. So I have a plane, name it plane D. And then RS, the line RS is not in this plane. So it can go through the plane, but it just can't be in it. So I could draw a line that goes through this plane, it hits the plane, it goes through it to the back and comes out the other side. So notice I put the little dashes to show that it went through the plane, and I'm going to name this R and S. So that's how you name points, lines, and planes, and looking at pictures and how to determine how to name things.